Welcome back to the Computer Science Department here at Western Washington University. I'm still Aaron Clausen, and I'm sorry. Sean Basler is still the brains behind the whole operation. He's taking the videos, he's posting things to YouTube, and really making all of this happen. So if you've been following along, up until now we've been talking about how we can move data around the system, how we access locations in memory, how we can use registers to do calculations. Today we're going to talk about the basics of function calls. Now when I talk about basics, I mean very basic function calls. Imagine that you have a function a void function that takes no arguments and performs no operations. I mean very basic function calls. If we went down to main, we're talking about a function call like this. So this function call, so this is our C world. If we go to the x86 world, this function call down here in main, the instruction is just call fun. Right? If we go up to our function, we need this label. Well, that label ends up looking like that. This is the general syntax. And this is actually where the goto instruction comes from. This is just a label. It just refers to a location in memory. This call is really a goto. Go to the symbol fun. Here is the symbol fun. All this function does is return. There's our return instruction. Notice it doesn't return a value. This is not the return statement that returns a value from a function. This is just the return instruction that says, I'm done doing what I need to do. Go back to where I was called. Well, that's sort of an interesting problem. This is easy. Jump there. This is a little more difficult. Go back to whoever called me. Because fun could be called from 5 or 6 or some arbitrary number of locations throughout the program. And this return, when it executes, needs to return to the right call location. Well, each one of these instructions has an address in memory. So let's say this is 1, 2, 3, 4. This is 1, 2, 3, let's say 5, though it's probably not a 1-byte instruction. And let's say that at 1, 2, 3, 5 is a move long EAX to the address 18. Just moving whatever was in the EAX register to address 18. Something simple. Somehow this call instruction needs to communicate to the return where this should return to. And the way it works is through the stack. So we've talked about the EAX register. We can move data to it, from it, we can do arithmetic with it. Another register that we had is the stack pointer, ESP. The stack pointer actually holds the address of a location in memory. Now generally when we draw this memory picture, we put the big addresses at the top. 0 is down here at the bottom. Somewhere in there is our stack. The stack pointer points at the last piece of memory that is used. So 9, A, B, C. Some piece of data, I don't know what's there. When the call executes, it says, hey, jump to the function. Jump up here. But it also takes the address of the very next instruction and pushes it onto the stack. And causes the stack pointer to point there. Thread of execution jumps up here, it does some work, in our case, very little work, and then executes a return. What return does is say, hey, I want to go somewhere, and the place I want to go to is whatever the stack pointer is pointing at. So in this case, we're going to jump to 1, 2, 3, 5, When the return statement executes, we jump down here to the move, which is exactly the behavior we want. In our C program, once function returns, once the call to fun returns, we want to continue with whatever else we were doing. And it's alighted. Let's make this a little more complicated. Rather than not doing anything, let's actually return something. Let's return an integer. And let's actually return the integer 5. Right? So we actually have to do a little more work up here in our fun function. Instead of just returning, we actually have to somehow communicate this value back to our main function. And the way we do that is with a convention that we use EAX to hold the return value. There's no hardware requirement for this. This is just what we decided to do. So in order to return the literal 5, what we need to do is a move. We need to move the literal value 5 into the EAX register, and then return. And then we return to this instruction, and it captures the return value and puts it into the address 18. Probably some global variable g equals the return value of function, or something similar. Notice that these two instructions, these two instructions correspond to that return statement. So this return actually does two things. It says, this is the value I want you to put into EAX. And I'm done executing the function return to the call site. And that's where our return instruction comes from. So here's the basics of a function call in the x86 world. We have call and return. Call jumps to the function, jumps to the label, and then saves the address of the next instruction onto the stack. The function does whatever it needs to do. In the end, it sets whatever its return value is into the EAX register. Executes the return. The return looks at the stack pointer, finds that address, jumps there, and then actually pops this off of the stack. And then we can continue to execute. Now, there's a few more things we need to make this useful. We don't have arguments yet. We don't have local variables. But that's a topic for the next video.